All right, get ready because today we're going deep, really deep into a situation where, well, it's a bit unnerving. It's where your body, your own immune system, decides to attack you.
And not just anywhere, it goes after the connection between your nerves and muscles.
Yeah, nerve-muscle connections are the enemy, according to your immune system in these cases. But don't worry, it's actually super fascinating. More fascinating than it is scary, really.
What we're looking at today is a lecture, and it's by Dr. Mohammed Al-Shourbaghi. He's a professor of pharmacology and toxicology.
Okay.
And what's really interesting is that this lecture, it's the last one in his series, his whole series on drugs that affect the autonomic nervous system.
Oh, wow.
So it's kind of a fitting way to wrap things up.
Yeah, the grand finale. And what better way to end this series than with two conditions that really show us just how powerful the immune system is, but also how it can go so wrong.
You got it.
We're talking about myasthenia gravis, MG, and Lambert-Eaton syndrome.
Both of these conditions, they mess with the communication between your nerves and your muscles, and that leads to a whole bunch of problems for people.
Yeah, it's a pretty delicate system.
It is. And the way these conditions disrupt it by going after very specific parts of how the signals are sent, that's what makes it so interesting.
Okay, so let's start with myasthenia gravis, MG. I mean, even the name grave muscle weakness kind of gives you a sense of what we're dealing with here.
It does, yeah.
So how does this happen? How does your immune system cause muscle weakness?
So with MG, what happens is your immune system, it starts producing these antibodies. And these antibodies, they mistakenly attack the nicotinic acetylcholine receptors. They're at the neuromuscular junction.
The what choline receptors?
Acetylcholine.
Acetylcholine, okay. And where are those at the neuromuscular junction?
Yeah, you can think of these receptors like doorways on the muscle fibers.
Okay.
And they're waiting for a very specific key to unlock them. And that key is the neurotransmitter acetylcholine.
So acetylcholine is like the messenger sent from the nerve.
Right.
It carries the signal to contract. And it has to fit into the right doorway or receptor on the muscle to actually deliver that message.
Exactly. But in MG, the problem is that the antibodies, they block or even destroy those doorways.
Oh, no.
So the acetylcholine, it can't bind.
So the message gets lost, and the muscle, it doesn't get the signal to contract.
Right.
Okay, no wonder people with MG have muscle weakness. But what kind of symptoms do they actually experience?
Well, it can be a lot of different things, and it varies from person to person.
Yeah.
Some people, they might have droopy eyelids, or they have trouble swallowing, or they can't speak clearly, or their facial muscles could be weak, and that leads to asymmetry.
I see.
And in more severe cases, this weakness can affect the muscles that you need to breathe, like your diaphragm.
Oh, that's scary.
It can be, yeah.
Before we get too ahead of ourselves, let's back up for a second. I want to make sure I really understand how this whole communication system between the nerves and the muscles, how it works in the first place.
Okay, good idea. So imagine you decide to pick up a book.
Okay.
So that signal starts in your brain, it travels down your spinal cord, and then it reaches a motor neuron that connects to the muscle you need to use to pick up the book.
Okay, so far so good. The signal's on its way.
Right.
But there's a gap between the nerve ending and the muscle fiber itself, isn't there? How does the signal get across that gap?
Right. That gap is called the synapse, and that's where acetylcholine, the neurotransmitter, comes in.
Okay.
It's released from the nerve ending, and it travels across that synapse, and it binds to those nicotinic receptors on the muscle fiber.
Okay.
That triggers a whole cascade of events that lead to the muscle contraction.
So acetylcholine is the key that unlocks the muscle contraction.
You got it. It's a really beautifully orchestrated system.
Yeah.
Until those antibodies in MG mess everything up.
Yeah, and Dr. Al-Shourbaghi, he really breaks down how those antibodies cause such havoc.
He does.
And it's not just blocking the receptors, right?
No, he talks about three main ways that they cause problems.
Okay.
The first one is they actually destroy those nicotinic receptors.
Oh, wow.
The second thing is they flatten the folds on the muscle fiber where those receptors are located.
I see.
And the third thing is they actually widen the synaptic cleft itself, making it harder for the acetylcholine to even reach its target.
So it's like they're not just jamming the lock on the door, they're tearing down the porch and digging a moat around the house.
That is a great analogy.
It really is, though. And all this results in weaker muscle contractions.
Yeah.
It's like trying to power a light bulb with a dying battery.
So how do doctors even diagnose something like MG?
Well, one of the biggest clues is the pattern of muscle weakness.
Okay.
Typically, it gets worse with activity, and then it improves with rest.
Okay.
And also, the muscles that are affected first, they tend to be certain ones, like the ones in the eyes, eyelids, face, and neck.
So the doctors are looking for telltale signs and patterns.
Yeah. But Dr. Al Shorbaghi, he also mentions antibody tests, right?
He does, yeah. And actually, for most generalized cases of MG, doctors can actually find those antibodies against the nicotinic receptors in a simple blood test.
That's amazing.
It is.
Science is so cool. But what about the cases where the antibody test isn't conclusive? What happens then?
Well, there's another test called electromyography.
Oh, God.
EMG, yeah, it's a mouthful.
Yeah.
Basically, what this test does is it measures the electrical activity of your muscles
Okay.
in response to nerve stimulation. And so in somebody with MG, what you would see is a decreased response,
Yeah.
which indicates that signal transmission is being compromised.
So it's like checking the wiring to make sure the signal is actually getting through.
Yeah,
Makes sense. Dr. Al Shorbaghi also talks about something called the idrophonium test.
he does.
But he mentions that it's not used very often these days. Why is that?
Well, with this test, they inject a short-acting medication that temporarily boosts acetylcholine levels. And if muscle strength improves after that injection, it kind of suggests that it might be MG.
I see.
But it has some limitations and it can be risky, so it's not really the go-to method anymore.
Okay, so let's say you are diagnosed with MG. What are the options? Can you actually fix those damaged receptors?
Well, unfortunately, we can't repair the receptors directly,
Oh, no.
but there are three main ways that doctors can try to manage the condition. The first one is to try to increase the amount of acetylcholine that's available at that neuromuscular junction.
Okay.
And we do that with medications called acetylcholinesterase inhibitors.
So instead of fixing the door, you're just flooding the porch with more keys, hoping that some of them will find a way in.
That's a great way to put it, and it can actually be quite effective.
Yeah.
The problem is that these medications can cause side effects because acetylcholine is used in other parts of the body as well.
Oh, so it's like using a sledgehammer when you really need a scalpel.
Kind of.
What about the second approach? Is that more targeted?
The second approach focuses on trying to calm down the immune system's attack.
Okay.
Basically, we're using medications that suppress the immune system. They're called immunosuppressants, and they reduce the production of those harmful antibodies.
So it's like telling the immune system to just chill out and stop attacking those poor receptors.
Exactly. And by dampening the immune response, you can potentially slow down the progression of the disease and give the remaining receptors a fighting chance.
That makes sense. And the third approach, thymectomy, that sounds like a pretty big deal.
It is surgery, but for some people with MG, removing the thymus gland can actually improve symptoms a lot. The thymus, it's part of the immune system.
Right.
And it seems to play a role in producing those harmful antibodies.
Right. So taking it out can actually help. That's pretty drastic, but I guess it shows you just how complex and interconnected our bodies really are.
It really does. And even with these treatment options, living with MG can be really tough.
Yeah.
It requires ongoing management and sometimes even lifestyle changes.
Absolutely. But before we get into the specifics of managing MG, I think we should switch gears for a minute and talk about the other condition we're looking at today. Lambert-Eaton syndrome.
Okay, sounds good.
LES, as it's often called.
Right.
It's another autoimmune condition that affects the neuromuscular junction. It also involves antibodies, but this time they're attacking a different target.
They are, yeah.
Oh, what are they going after at LES? Are we still using that porch analogy?
We can stick with the porch.
Yeah.
So in LES, instead of attacking the doorways, the antibodies, they go after the mechanism that releases the keys in the first place.
Whoa. Okay, so what do you mean?
They attack what's called voltage-gated calcium channels on the nerve ending.
Okay, break this down for me. What do these calcium channels do, and why are they so important?
All right. These calcium channels, they're absolutely crucial for the release of acetylcholine. Think of them like the key masters inside the nerve ending.
The key masters, okay.
Yeah. So when a nerve signal comes in, these channels open up, and that allows calcium to flow in. And that influx of calcium is what actually triggers the release of acetylcholine into the synapse.
Oh, I see. So in LES, these key masters are under attack, which means fewer keys are getting released.
Exactly.
And that leads to muscle weakness, just like in MG.
Right. But there are some key differences in how it shows up, the pattern, and the types of muscles that are affected.
Interesting. So even though both conditions cause muscle weakness, the underlying mechanisms are different. It's like two different ways to disrupt the same communication system.
Exactly. And that difference in how they disrupt the system is going to play a role in how we approach treatment.
All right, I think this is all incredibly fascinating, but I think we've given our listeners a lot to process. So let's stop here and we'll pick up this conversation in the next part of our deep dive. We'll explore the nuances of Lambert-Eaton syndrome, and then we'll dive into the treatments for both conditions in more detail. Don't go anywhere.
Sounds good. You know, it's really amazing when you think about it how these two conditions, AG and LES, they really highlight how complex the nervous system is.
They do, yeah.
I mean, we just take for granted things like picking up a glass or walking, but there's so much going on behind the scenes to make those things happen.
It really is like this perfectly choreographed dance, and if just one thing is off, the whole routine falls apart.
Exactly.
So before we get into the treatments for both MG and LES, let's circle back to Lambert-Eaton syndrome for a minute.
Okay, sure.
You mentioned that there are some key differences in how it shows up compared to MG.
Yeah.
What are some of the things that our listeners should be aware of?
Well, one thing is that while both conditions cause muscle weakness, in LES, it's more noticeable in the limbs, especially the legs.
Okay.
So imagine having trouble climbing stairs or even just getting up out of a chair.
Yeah.
That's the reality for a lot of people with LES.
That sounds so frustrating.
It is.
And I mean, if you didn't know any better, you might just think it's normal muscle fatigue.
Right. Right.
Are there any other red flags that can help distinguish LES from MG?
Yeah, one interesting thing about LES is that muscle strength can actually improve for a bit after exercise.
Really?
Yeah, it seems counterintuitive. But what happens is that repeated nerve stimulation can actually help overcome that blockage that's caused by the antibodies on the calcium channels.
Oh, so it's like giving those key masters a little nudge to release more acetylcholine.
Exactly. And another clue is that people with LES, they often have other symptoms too, like autonomic symptoms.
Okay.
Things like dry mouth, constipation, or even low blood pressure. And these symptoms, they happen because the nerve signals in other parts of the body are being disrupted, not just the ones going to the muscles.
So the effects of those antibodies go way beyond just the neuromuscular junction. So that makes LES even more complex to manage.
It does.
Speaking of management, what are the treatment options for LES? Are they similar to the ones used for MG?
There is some overlap. Acetylcholinesterase inhibitors, remember those medications we talked about that increase acetylcholine levels?
Right, yeah.
Well, those can also be helpful in LES, but there are two other medications that are specifically used for LES.
Right.
They're called 3,4-diaminopyridine and 4-aminopyridine.
Wow, those are mouthful.
I know, right?
How do those medications actually work? How do they help improve muscle strength?
Well, these medications, they work by blocking a different type of channel.
Okay.
They block voltage-gated potassium channels. Potassium channels, they help repolarize the nerve ending after it fires, allowing it to reset and fire again.
Okay.
So by blocking these potassium channels, what we're doing is we're basically prolonging the time that the nerve ending stays activated.
I see.
That gives those calcium channels a little bit more time to release acetylcholine.
So instead of boosting acetylcholine levels directly, you're sort of manipulating the electrical properties of the nerve ending to squeeze out more acetylcholine, like tricking the system to work around those antibodies.
You got it. That's a great way to put it. And this strategy can actually be pretty effective in improving muscle strength and reducing fatigue for people with LES.
That's great. Now, going back to MG for a second, you mentioned earlier that thymectomy can be an option for some people.
Right.
Can you tell us a little bit more about that? How does removing the thymus gland actually help with MG?
We don't fully understand why, but for a lot of people with MG, the thymus gland seems to be producing these abnormal T cells.
Oh, yeah.
Those T cells are the ones that attack the acetylcholine receptors.
Right.
So by taking out the thymus, you can reduce this autoimmune response, and that can lead to a really big improvement in symptoms for some people.
So it's like taking out the source of the problem, like the factory that's producing those defective immune cells.
Exactly.
But surgery always comes with risks.
Right. It does. You're absolutely right. It's a major decision, and it's not the right choice for everybody with MG. Doctors will carefully consider all sorts of factors for each individual. Things like their age, how severe their symptoms are, and how they've responded to other treatments. All of that goes into deciding whether or not thymectomy is a good option.
So it's about weighing the potential benefits against the risks.
Exactly.
What about those other treatments we were talking about, like immunosuppressants and acetylcholinesterase inhibitors? Are there any downsides to using those?
Yeah, so immunosuppressants, they can be really effective at calming down that immune response, but they can also make you more vulnerable to infections.
Right, because the immune system, it's not just fighting off those misbehaving T cells, It's your body's defense against all sorts of threats.
Exactly. So it's a trade-off. You're trying to reduce the MG symptoms, but you might be increasing your risk of getting sick.
I see.
And then with the acetylcholinesterase inhibitors, the side effects are usually not as serious, but they can still be annoying.
Yeah.
Things like nausea, diarrhea, abdominal cramps, increased salivation, and even a slow heart rate.
Yuck. None of that sounds fun.
No, not really. It's kind of like your body's fighting a war against those antibodies, but there's always some collateral damage. It really shows you just how delicate the balance is in our systems.
It does, yeah. And it really highlights the importance of working closely with your doctor to find the treatment that's right for you and to manage those side effects.
You're absolutely right. There is no one-size-fits-all approach.
Yeah.
Everyone needs a personalized plan, one that's tailored to their own individual needs and challenges.
That makes sense. And that's why research is so important, right?
It is, yeah. Scientists are always looking for new treatments that are more targeted, that have fewer side effects. And they're also looking for ways to personalize treatments based on individuals' genes.
It's pretty amazing to think that maybe one day we'll be able to predict who is at risk for these conditions so we can intervene early or even prevent them altogether.
That's the dream. But until then, we just have to keep raising awareness, supporting research, and empowering people with MG and LES to advocate for themselves and get the best care possible.
Well said. You know, this whole conversation has really shown me how incredibly complex the nervous system is.
It is.
I mean, we just take it for granted, but every single movement, every thought, every sensation, all relies on this intricate network of communication.
Right.
And when that network gets disrupted, it can have huge consequences.
Yeah, it really makes you appreciate how interconnected our bodies are.
It does. And it reminds us that there's always more to learn.
Always.
All right. I think we've covered a lot of ground today. But before we wrap up our deep dive into MG and LES, there's one more thing we need to touch on, and that's the psychological impact of living with these conditions.
Oh, yeah, that's an important point. It's not just about the physical symptoms.
Right.
Imagine how emotionally draining it must be to deal with unpredictable muscle weakness.
Yeah.
The frustration of not being able to do things you used to be able to do, the fear of complications, all of these things can take a huge toll on your quality of life.
It's a good reminder that healthcare isn't just about treating the physical body, it's about caring for the whole person, their emotional and mental well-being too.
Exactly. And that's where support networks can be so crucial. Family, friends, support groups, therapists, all of these can play a really important role in helping people with MG and LES cope with the challenges they're facing.
It's about building resilience, finding ways to adapt, and staying positive even when things are tough.
Exactly. And remembering that you're not alone. There are other people out there who understand what you're going through, and they can offer support and encouragement.
This has been a truly insightful conversation, and I'm sure our listeners learned a ton about MG and LES. But before we wrap things up, I'm curious, are there other conditions that can affect the neuromuscular junction that we haven't talked about today?
That's a great question. There are actually quite a few other conditions that can mess with neuromuscular transmission.
Oh, wow.
Some are genetic, like congenital myasthenic syndrome, where certain proteins involved in the neuromuscular junction, they're faulty right from birth. And then others are caused by toxins or even medications that interfere with acetylcholine, either its release or how it binds.
Wow, so there are all these different ways this delicate system can be disrupted.
Yeah.
It really makes you appreciate all the research that's going on and how dedicated these scientists are to unraveling all these mysteries.
Absolutely. There's still so much that we don't know. But with every new discovery, we're getting closer to finding better treatments and improving the lives of people living with these conditions.
This has been such a fascinating deep dive. I've learned so much. But I think we've given our listeners a lot to think about. So let's take a quick break to recap the key takeaways and offer some final thoughts for our listener. We'll be back in just a moment for the last part of our exploration of myasthenia gravis and Lambert-Eaton syndrome. Stay tuned. And we're back for our final look at myasthenia gravis and Lambert-Eaton syndrome.
It's been quite a journey exploring these conditions.
It really has. We've gone from the nitty-gritty of how the neuromuscular junction works all the way to the complexities of autoimmune disorders.
Yeah, and we even touched on what it's like to actually live with these conditions, the emotional side of things.
And through it all, we've seen how amazingly resilient the human body is and how clever researchers and clinicians are. They're constantly learning more and finding new treatments.
Absolutely. But, you know, it's easy to get caught up in all the details and forget where we started.
You're right. We started with Dr. El-Shorbagy's lecture.
Exactly. And his lecture, remember, it's the last one in a whole series about drugs that affect the autonomic nervous system.
Oh, yeah, that's right.
And it's really neat how he uses MG and LES as examples of how we can target specific receptors to manage these really complex neurological conditions.
It's like the perfect wrap-up for the whole series. It brings together everything we've learned about the nervous system and all the tools we have now to affect it.
It really does. And it makes you realize that understanding how these mechanisms work, it's not just important for MG and LES, it's relevant for a bunch of other neurological disorders too.
Yeah, it's like cracking a code, and it opens up doors to all kinds of new treatments or possibilities.
Exactly. And it makes you appreciate how far we've come in the field of neuropharmacology.
Can you imagine going back in time just a few decades and telling people that we'd be able to manipulate nerve signals with this level of precision?
They'd think we were crazy. It would sound like science fiction.
Well, speaking of the future, what do you think is next for research in this area?
I think personalized medicine is going to be huge. Imagine tailoring treatments for each person based on their genes or their specific antibodies.
Wow, it'd be like designing a custom treatment plan.
Exactly. And that could mean more effective treatments with way fewer side effects.
We're also seeing so much progress in regenerative medicine.
Yeah.
Who knows, maybe someday we'll be able to actually repair those damaged neuromuscular junctions or even replace them completely.
That would be incredible. It'd be like hitting the reset button on these conditions.
Wow. The possibilities really are mind-blowing. But even beyond all the fancy technology, I think the biggest takeaway for me is the importance of awareness and advocacy. The more we understand about these conditions, the better we can support those who are affected and help push research forward.
Absolutely. Knowledge is power, and when we share that knowledge, we can help people, their families, whole communities take control of their health.
And on that note, I think it's time to wrap up our deep dives into myasthenia gravis and Lambert-Eaton syndrome. It's been quite a journey, and I hope you, our listener, have a better grasp of these conditions now.
Yeah.
And more than that, I hope you've gained a sense of awe for the human spirit and its ability to overcome challenges.
Me too. It's been great talking about all this with you, and I want to encourage everyone listening to keep learning, keep asking questions, and never stop exploring. There's always something new to discover.
Absolutely. Until next time, stay curious, stay informed, and keep exploring all the amazing things the human body can do. This is The Deep Dive, signing off.